Hey, hello everyone. In the fourth chapter of Energizing Physics, students will learn about force and motion.
That's right, Aaron. In this chapter, students will learn how to use Newton's second law of motion to connect an object's motion to the forces causing that motion.
By the end of the chapter, students will be able to break down motion using graphical and algebraic methods.
To demonstrate their understanding, students will use their new tools to connect the motion seen in a short video clip to the forces required to generate that motion.
Though this chapter involves vectors, the motion we look at here is all one-dimensional. Students will need to deal with positive and negative numbers, but won't need trigonometry. If you are looking for more advanced topics, such as projectile motion, collisions, etc., check out Chapter 8.
As with other Energizing Physics chapters, the main focus is building students' conceptual understanding. All through the chapter, concepts spiral, giving multiple chances for students to make connections along the way.
In the Energizing Physics sequence, students are finally ready to take on acceleration and more detailed descriptions of motion. We explore motion with questions like, do people walk or run at a constant speed? Do things fall at a constant speed? What does it mean if a position-time graph is a curve? We finally need the concept of acceleration. We challenge students to collect data and make graphs to answer these questions. The data is messy, but the challenge is rich. Once we've defined acceleration, students investigate Newton's second law. We write it as A equals F net over m and use the accelerometers on students' mobile devices to measure the acceleration of a box, varying the forces applied and the box's mass. We add more tools and connections about motion, including how slope and area can be used to relate position, velocity, and acceleration. We can analyze everyday 1D motions such as throwing a ball up in the air using these tools. No calculus is needed, and we stick mainly to constant acceleration situations. By the end of the chapter, students can analyze a video to calculate the forces involved. They have to estimate time and distances in the video and choose the models to apply. The action could be from a Hollywood blockbuster or a great sports play. This proves to be a challenging application of the chapter ideas because students aren't given any numbers. They have to make measurements and estimates and build a model themselves. To recap, the first two activities explore the concept of acceleration and begin playing with motion graphs. 4.3 defines acceleration as the change of velocity divided by the change of time. 4.4 introduces and applies Newton's second law. 4.5 builds more skills with graphs, including finding areas. And 4.6 builds and uses algebraic tools for analyzing constant acceleration. Finally, the project gives a fun, authentic, and open-ended challenge. We hope you and your students enjoy Chapter 4.